Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI cookbook series where we learn and implement design patterns for AI applications using hands-on example. In our previous video, we explored the parallel execution pattern in Agentic AI and began implementing an automated marketing email generation use case. We walked through the use case in detail and built out the worker chains, learning how to fan out tasks and execute them in parallel for better efficiency and scalability. If you missed on my previous videos, I will share the link in the description, so be sure to check it out before continuing. Alright, let's take this forward and bring everything together. In this video, we will continue building our automated marketing email generation use case and move one step closer to a complete working solution. We will construct the graph, introduce the fan-in node to combine our parallel outputs, and finally run the entire application end-to-end to see how all the pieces fit in together in action. So let's begin. All right. So we need to create a fan-in node. Fan-in node will assemble all the information. So finally, final email chain to assemble all the information. All right, so what we need to create a prompt. Okay, that prompt will be a multi-line prompt. Combine the provided subject comma body and call to action text, that is CTA. Okay, into a concise readable email for marketing. Okay, now we need to provide some values. Okay, so subject would be subject, then we need to add in some value for body. Body would be body, and finally call to action or CTA. For this we need the value as CTA. Okay, so let's put a new line here and let's add two new lines here. All right, so this is the prompt that we need to introduce. Now let's create the chain. So it's going to be final email chain. Now as we recall from our previous video, we had created a create chain. So all we need to do is pass the prompt to the create chain. Okay, and the chain is created. Now let's write the final email node dev write final email, which will take a state which is an email state. Okay, as a shared schema, the description would be combine subject body and CTA into a final marketing email. All right, so let's invoke the email chain, final email chain. So it is email final email chain with invoke. We have three values now. First is the subject. So let's copy the value from here. and the value would be state, subject, then we have body, and again the value will be coming down from our schema, that is body. All right, and finally we have CTA, so this will be again coming down from state. Okay, so this is CTA. Now we have the email. Now we will return this, return as a partial dictionary. So it will have a key as final email, and the value would be final email. Okay, all right, so we have all the nodes. Now it's time for the graph, so let's initialize the graph. Initialize the graph. Okay, so for that we need a state graph. Okay, so let's import the state graph from the line graph. All right, from line graph dot graph import state graph, and we import end. Okay, all right, let's create the graph now. So it's going to be graph is equal to state graph, and it will inherit from, or it will be type of email state. Okay, now let's add the nodes. Add nodes. It's the same exercise we are doing what we had done earlier for other examples. So it's going to be graph dot add node, and the value would be, first is right subject. Okay, and the node would be right subject. Okay, again graph dot add node, right body, the value would be right body. Graph dot add node, and we are going to write CTA, and the value would be right CTA. All right, now we have the final email. So graph dot add node, write final email. So it is going to be right, sorry, we need to eliminate the errors, right final email. Okay, so we have all the nodes added. Now we need to create the fan out logic here. So what closely how we are doing? As we know, we have the gather data. Gather data is not a node, it's a function because it returns a sequence of send. So we are going to use add conditional edge, and we are going to add the value. So now we know that our application has to start from a particular node, so that will be the gather node. So let's add start, and we add the gather data. Okay, so now this is added. Let's go up and import start as well from the graph. Okay, so now we have added the gather data. Do note that gather data is not a node, it's just a function. All right, so let's add the edge. Graph dot add edges. So this edge will decide on from where to where this data will flow. So it's right subject. Let's copy paste it, right subject. From right subject it will go to final email. Okay, again graph dot add edge, so we can copy this entirely and instead of right subject we will have right body. Let's copy this, and finally we have right CTA. From right CTA again it will go to right final email where all the information is combined and consolidated. All right, we have included all the edges, but now the graph has to end somewhere. So let's add the final edge. It's going to be graph dot add edge, and it will go from right email to end. All right, so this will complete the graph. Now graph has to compile, so we will create an app out of graph. Okay, so this will create a graph. All right, now it's time to run the graph and see how it is performing, or have we achieved our goal. All right, if name equals to main, try while true, user input, or we can say user topic is input, and we can say enter topic, so it will prompt for user to enter a topic. Okay, and we will strip the extra white spaces. If not user topic, then continue. So it will continue till user enters a value through the keyboard. Finally it will invoke once it has the information. So result would be app.invoke. Okay, now invoke, we will invoke with the topic as a partial dictionary. So this is going to be a topic which will be the user input or user topic. All right, now let's print the value. So pp print topic, let's import the pp print here. Okay, from pp print import pp print. Okay, so this will print the, okay, so we will print the result, not the topic. All right, it will print the dictionary here. Okay, now finally it's time to accept any error. So it will be keyboard interrupt that we are going to accept, and in case of any keyboard interrupt we will say goodbye for now. All right, so let's run this and see. Okay, let's open the terminal. All right, which one? This is the marketing email. Couple of things to note, that what we have seen in our routing logic, we use the conditional edge, but there it was a node. Here, because it is returning a value or a array of send, which is basically a type of line graph, so it's a function and starts with a function. So all right, summer sale on running shoes, summer sale on running shoes. Let's go over the results. We had three values as we can see from our email state. The topic was the one that user entered, then we have subject, body and CTA, and finally a final email was generated. So we have topic as we see, then we have subject line, so we had list of subjects that was generated from the topic and LLM chose the best one. Then we have the CTA that was generated. Okay, call to action, that what they need to do or how they can attract customers. And we have the email body, as we can see that it has a dear name, so it's just like something you need to fill in up couple of details and it is good to go. Finally, a final email was drafted along with the email body, the subject line, and the call to action. All right. And that brings us to the end of our implementation of automated marketing email generation use case. We have seen how breaking complex tasks into independent units and executing them concurrently can significantly boost both speed and efficiency. In the next video, we will dive into another agentic AI design pattern with a hands-on implementation. So stay tuned. If you found this video helpful, don't forget to like, share, and subscribe for more practical insights into AI architecture and design patterns. Thanks for watching, and I will see you in the next video.